What is going on, Algebra Bros? It's Mr. C here, and in this video we're going to do a quick recap of synthetic division, which is a pretty important skill when it comes to finding the zeros of a polynomial function. So let's go ahead and dive into this first example. We want to divide 2x cubed minus x squared plus 2x minus 3 by x minus 1. And we're going to do that using synthetic division, and upon doing so we'll identify the quotient and remainder. Alright, so step 1 is to take the divisor, which is x minus 1, set it equal to 0, and solve for x. Step 2, we'll set up the synthetic division by drawing this little half box, a long equal bar, and underneath the equal bar to the far right, we'll go a second half box. And this number 1 is going to go inside our first half box, and you may recall that there are numbers that we write out directly to the right of this number, and those come from the coefficients of the polynomial, which is the dividend. Alright, so that would be 2, negative 1, 2, and negative 3. That's the setup for the synthetic division. Let's go ahead and execute it. So bring down the 2, and then what we do is we take the number in the top half box, multiply it by what we just got underneath the equal bar. 1 times 2 is 2, and then we add in column format. That gives us a 1, and we repeat this process until we get to the second half box. 1 times 1 is 1. Add it down, we get 3, and then 1 times 3 is positive 3. Adding these down, we get 0. So that is the synthetic division. The quotient is going to be a polynomial, and the coefficients involved in the polynomial are the numbers that are underneath the equal bar that come before the second half box. So namely 2, 1, and 3. Now the degree of the quotient will always be 1 less than what you're dividing. Alright, so keep in mind that every time you do synthetic division, you reduce the degree of the polynomial by 1. So our polynomial starts out as a degree 3, meaning that our quotient should have a degree 2. So that first coefficient is going to go in front of x squared. The second coefficient will go in front of x. And then the third coefficient will be the constant term of this quotient. And our remainder is 0. And that's it for that problem. Let's do another example. Same dividend but different divisor. Okay, this time our divisor is x plus 3. The first step is to take x plus 3, set it equal to 0, and solve for x. We get negative 3. And now we'll set up the synthetic division apparatus. We'll take negative 3 and put it in that first half box. And then the coefficients, 2, negative 1, 2, and negative 3 again. Spread that out a little bit more. Okay, we'll take the leading coefficient of our dividend underneath the equal bar, multiply by negative 3. Okay, that gives us negative 6. Adding down, we get negative 7. Multiplying by negative 3, we get positive 21. Adding these down, we get 23. And then last round of multiplication by that, we are going to get negative 69. And adding negative 3 to negative 69 gives us negative 72. Again, these will be the coefficients of our quotient. And we started out with a degree 3 polynomial dividend, which means our quotient is going to have a degree 2. Therefore, the first coefficient will go in front of x squared. The second coefficient will go in front of x. And then 23, which is positive, will be our constant term. And this time our remainder is negative 72. So I want to point out a couple of things regarding the synthetic division and how it kind of connects to the zeros of a polynomial function. In this next example, I made our dividend a polynomial function, and I'm requesting us to evaluate two particular inputs. Now the first input that I want us to evaluate is 1, the second is negative 3. And if you recall some of our work in those last two examples, 1 and negative 3 were the numbers that we performed synthetic division with. So check this out. If we plug 1 into this function, that's 2 times 1 cubed minus 1 squared plus 2 times 1 minus 3. This is going to simplify as 2 minus 1 plus 2 minus 3. It's 1 plus 2 minus 3, which is 3 minus 3. And ultimately we get 0. If we plug negative 3 into the function, it's going to be 2 times negative 27 minus 9 minus 6 minus 3. That's negative 54 minus 9 minus 6 minus 3. And this all combines to give us negative 72. And what do you notice about these two numbers? These two outputs happen to be the remainders when we did the synthetic division with these input values. In particular, the remainder we got when we did synthetic division with 1 was 0, and the remainder we got when we did synthetic division with negative 3 was negative 72. Now, since plugging 1 into the function gave us an output of 0, it would mean that the number 1 is a real 0 of this polynomial function. Okay, so throw back to the last section. Since the remainder we got with negative 3 is negative 72, that would imply that negative 3 is not a real 0 of f of x. So kind of keep that in the back of your mind as we work through the rest of the examples for this section. But I'm going to close out the video with what we noticed regarding the remainders and the numbers that we did synthetic division with. And it's no coincidence that that happened. It's actually the result of two theorems known as the remainder theorem and the factor theorem. And the remainder theorem says that if a polynomial function is divided by the expression x minus r, then the remainder is f of r. Okay, so when we were working with the first synthetic division example, we were trying to divide by x minus 1. And in this case, 1 is like our r value, and what we ended up plugging in was f of 1. In the other example, we had x plus 3, which could be rewritten as x minus negative 3, which is why in this case r is negative 3, and that's what we ended up plugging into our function, was negative 3. So that's actually the whole point of why I do step 1 in synthetic division, is when I set the divisor equal to 0 and we solve for x, the solution we get for x is the true value of r. Alright, but back to the theorem. When you divide a function by x minus r, the remainder is f of r. Okay, so it's the opposite of the number in the factor that gets plugged in. As an added bonus, if f of r equals 0, then what that would mean is x minus the real number you're plugging in is a factor of the function. So this relates to material from our previous section. We know that 1 is a real 0 of that function we were working with, which that implies that x minus 1 is a factor of f of x. So if we wanted to factor f of x, x minus 1 would be one of the factors. We could not build a factor of x plus 3 when factoring f of x, because we know that negative 3 is not a real 0. So in other words, the fact that we got a remainder of 0 when we did synthetic division, in other words, when we divided the function by x minus 1, implies a couple of things. Number one, x minus 1 is a factor of the function, and 1 is a real 0 of it. Alright, pretty mind-blowing stuff. So I'm going to leave the video there. Let me know if you have any questions. Otherwise, thanks for watching, and I'll see you in the next one.